My dear students, suppose a surd is given to you of this form a plus square root of b, and you are asked to find the square roots of this surd. Let us see if we can find a general formula so that you can find the square root of the surds which look like this. So let us see. So basically you have to find out this square root of a plus square root of b. Now here I must say one thing. If the problem says like this, you have to find out the square root of a plus square root of b simply like this, then as we all know, square roots of a particular real number, particular non-negative real number produces two answers, plus and minus. Suppose you have to find out the square root of 4. Square root of 4 is plus 2 and minus 2. But if I tell you find out this only, so basically I am already putting a positive sign over here. It means that you have to find out this only. Okay. So if the problem goes like this, square root of a plus square root of b, that means you have to find out the positive part only, positive answer only. But if I tell you that you have to find out the square roots of a plus square root of b, then you have to find two different answers, one with a plus sign, another with a minus sign. Let us keep those debate aside and concentrate on this one. So how can we find a general formula for this? See, if you look closely, suppose I write square root of x plus square root of y and I square it. What I get? Square root of x whole square means x plus 2 into root x into root y plus square root of y whole square means y. So if I just interchange the positions, you have x plus y plus 2 square root of xy. Now if you look at this and this given form, just remove the square root part. See, we can relate these two forms. How? You have a non-rooted portion a and a square root portion square root of b. So non-square root portion plus a square root portion. Over here also see there is a non-square root portion and a square root portion both added together. So if anyhow we can relate these two, we can proceed with the problem. So for the time being, let us assume that square root of a plus square root of b means square root of a plus square root of b is of the form square root of x plus square root of y. Let us assume that. So based upon that assumption, you can write let square root of a plus square root of b is equal to root x plus root y. Let us assume that this be of this form, where obviously when you are writing square root of x plus square root of y, x and y should be greater than 0, and over here b is greater than 0, means greater than equal to 0. It can be 0 also. But if it becomes equal to 0, then it is not a surd over here. So just to remove all controversies, let us assume that b is greater than 0, x is greater than 0, y is greater than 0. Okay. Now if you square both sides, what you get? A plus square root of b equal to squaring of this one. I have already shown that it becomes x plus y plus 2 square root of xy. Now if you compare both sides term to term, this part is equal to this part and this part is equal to this part. So just comparing the parts, comparing, what you get? A equal to, or rather say x plus y equal to a. Let this equation be named as equation 1, and we get 2 square root of xy equal to square root of b. Let this be named as part 2. Now see, from equation 1 you get y equal to x minus a, sorry, y equal to a minus x, and from equation 2, see, squaring this both sides, what do you get? 4xy equal to b, and from this you are getting y equal to a minus x. So putting that in place of y equal to a minus x over here, what you get? Or you get 4 into x into a minus x equal to b, that is, or 4x into a minus 4x square equal to b, which implies this being a quadratic equation, 4x square minus 4ax plus b equal to 0. Now this is a quadratic equation in x. Now this being a quadratic equation in x, we can apply Sridhar Acharya's formula over here, which implies x equal to, now applying Sridhar Acharya's formula, see what you get, 4a plus minus square root of 16a square four into b by 8. I mean, just simplifying this one, it gets 16a square minus 16b. So you can take 16 outside as 4. Now those 4 and this 8 will get cancelled out. You can do it in a copy and see. Ultimately everything will get cancelled out, and what will remain? So let us see what remains. It will remain only over here a, this will become 2, and inside you will have a square minus b only, a square minus b only. Okay, now if x is this one, what will be y? Now therefore y equal to a minus x, so a minus this portion. What is this portion? See, you can just simplify this one as, I'm just simplifying this one, it will be easier for us to calculate. This can be written as a by 2 plus minus square root of a square minus b by 2. So a minus x means this portion, so a minus a by 2. Now plus minus, if you introduce a minus over here, so it will become minus plus root over a square minus b by 2. A minus a by 2 means a by 2, so this becomes a by 2. So ultimately x is this, y is this. So you can just put the values, the expressions of x and y over here, and you will get the square root of this surd. Now over here I must say you something, that see, this is valid when, now over here also there are certain conditions that will be applied over here so that this process is valid. If you look closely in the answer, you have a square root of a square minus b over here. Okay, just before that, let us just write the answer. I hope you all have understood this one. So we can just due to shortage of space, we can just remove these portions. So ultimately we had considered that square root of this one equal to root x plus root y. Now, therefore, this one is ultimately equal to square root of a by 2 plus minus root over a square minus b by 2 plus square root of a by 2 minus plus square root of a square minus b by 2. Now, the very first condition that is applied over here is that, see, under the root whatever you have, that cannot be less than 0. So, obviously, first condition is that a square minus b should be greater than equal to 0. Now, a square minus b being greater than equal to 0, this means that a square should be greater than equal to b. So, whatever problem will be given to you of this form, you will just have to check that to apply this formula, the square of the non-root term must be at least greater than or equal to the rooted term, rooted number. Okay. So, a square should be greater than equal to b. That is the condition. If that condition is fulfilled, then you can apply this formula over here. Now, see, if you look at this form, these two forms of x and y, and if you just remove this plus minus or minus plus, see, remaining terms are same. So, what does it imply? It implies that you can get two answers over here, one with plus, another with minus. That's one thing. And if it is plus over here, it will be minus over here. If it is minus over here, it will be plus. So, just you can write this one. If it is plus, then this will be just minus. See, if you would have considered minus over here, this would have been plus. So, the same thing. So, today what we have seen is that if the problem goes that you have to find square root of a plus square root of b, the formula is this. So, we have today arrived at a formula for finding square roots of the surds of this form.